Welcome back to section 5.2. We're still working on verifying these identities. So what you want to make sure is you still have your Pythagorean identities and your trig identities with you for reference as we're going through. All right, so we want to work with either the left-hand side or the right-hand side. For this one, let's try working with the right-hand side. So we're going to keep the left-hand side as is. Cosecant of x plus cotangent of x equals. Now, once again, when I see that 1 minus, I'm thinking let's use its conjugate. So we're going to multiply the numerator by 1 plus cosine of x. And this is just a technique you're going to use depending on this situation. When I see a conjugate, I like to add its conjugate or multiply by its conjugate. So what we're going to get in the numerator, I'm going to keep it as sine of x times 1 plus cosine of x over, and now 1 minus cosine x times 1 plus cosine of x is 1 minus cosine squared of x. Once again, that should be ringing some alarm bells. Sine squared theta plus cosine squared theta equals 1. Subtract cosine squared theta from both sides. So we get sine squared theta equals 1 minus cosine squared of theta. So now, instead of writing 1 minus cosine squared, we can replace that with sine squared. So my denominator, I'm going to have sine squared x. All right, so on the left-hand side, we still have the cosine of x plus the cotangent of x. So the cosecant of x plus the cotangent of x equals. Now, sine of x over sine squared. Now, sine squared, keep in mind, that's just sine times sine. So the sign on top and one of the signs on the bottom cancel, so we're left with 1 over the sine of x there. So what we end up with is 1 plus cosine of x over the sine of x. All right, we're getting close. We want to get a cosecant plus a cotangent. Cosecant of x plus cotangent of x. So we can split up the fraction 1 over the sine of x plus the cosine of x over the sine of x. Now, 1 over the sine of x, that's the cosecant of x. And cosine over sine is the cotangent of x, and that's exactly what we wanted on the right-hand side, on the left-hand side. There we go, we just verified that identity. Let's try some more. Once again, when I see like a 1 plus cosecant or a cosecant plus 1, I'm thinking conjugate. Or what we can do is I'm seeing that cotangent squared. There's a couple different ways to do this, like I said. So you could either use the conjugate or 1 plus the cotangent squared theta equals the secant squared, cosecant squared theta. So cotangent squared is the same as cosecant, can't spell, cosecant squared theta minus 1. So what I can do is I can put cosecant squared theta minus 1 over 1 plus cosecant theta. Okay, so now when I see that cosecant squared, I can factor that. So cosecant squared, that's in that form of a squared minus b squared. That's in that a plus b, a minus b form. So when I factor that, I get the cosecant of theta plus 1, cosecant of theta minus 1 over 1 plus the cosecant of theta equals 1 minus sine theta over the sine of theta. It's a tricky one. Now, order doesn't matter for multiplication. Cosecant of theta plus 1, 1 plus cosecant of theta, they're the same. They cancel out. So we end up with the cosecant of theta minus 1 equals 1 minus the sine of theta, all divided by the sine of theta. Weird. Now, cosecant, that's 1 over sine. So we have here is 1 over the sine of theta minus 1 over 1. And you'll see why I did that in a moment. 1 minus sine theta over the sine theta. In order to add fractions, we must have a common denominator. 1, we'd multiply by sine theta over the sine of theta. So we're left with 1 over the sine theta minus sine theta over the sine theta. So what we get when we add those fractions, 1 minus the sine theta over the sine theta equals 1 minus the sine theta over the sine theta. That was a tough one. There's probably a better way to do that, and I'm sure we can discuss that in class as well. But that's one of the ways to do it. All right, let's do some more. So we can work on either side. It doesn't matter. So for these, looking at it, there's not a whole lot I can really do with tangent to the fourth. I'm going to work on the right-hand side. So tangent to the fourth x equals. Now looking at this, I can factor on the right-hand side, a tangent squared. So that gives me tangent squared of x times secant squared of x minus 1. Now, I know I need to get to a tangent to the fourth, and secant squared and 1, that looks familiar. Remember our Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. So if I get secant and 1 on the same side, subtract 1 from both sides. Tangent squared theta equals secant squared theta minus 1. So now, we still have tangent to the fourth of x on the left-hand side, and on the right-hand side, tangent squared of x times, and we can substitute in place of secant squared x minus 1, a tangent squared of x. So now, if you look, tangent squared times tangent squared, that's just tangent to the fourth of x. So tangent to the fourth of x equals tangent to the fourth of x. We got it. Once again, left-hand side, I don't really see a whole lot I can do there, but on the right-hand side, there's maybe some things I can do. So for this, sine cubed x cosine to the fourth of x equals. Now, between those two terms, I can factor out a cosine to the fourth. So what I get is cosine to the fourth of x. And when I factor that out, I get 1 minus cosine squared of x. And I should have big parentheses around the whole thing because we're still multiplying that by the sine of x. Now 1 minus cosine squared, that should be throwing up some alarm bells. Remember, sine squared theta plus cosine squared theta equals 1. Get cosine and 1 on the same side, so I subtract cosine squared theta from both sides. Sine squared theta equals 1 minus the cosine squared of theta. So in place of 1 minus cosine, I can put sine squared. Cosine to the fourth of x times, instead of 1 minus cosine squared of x, I get sine squared of x times sine of x. And on the left-hand side, sine cubed x, cosine to the fourth of x. And you can see sine squared times sine is sine cubed. And then we still have that cosine to the fourth of x. And that's what we wanted. Sine cubed of x, cosine to the fourth x equals sine cubed x, cosine to the fourth x. Looking at this one, I need a cosine to the fourth of x equals times cotangent of x. I'm going to rewrite the right-hand side. So I have my cosecant squared of x, and now cotangent of x, cotangent cubed of x. I can factor out a cotangent. And when I do that, I get 1 plus cotangent squared of x. And that should be throwing up some alarm bells. Remember, 1 plus the cotangent squared of theta equals the cosecant squared of theta. So instead of writing 1 plus cotangent, I can put cosecant squared. So on the right-hand side, I have cosecant squared x times the cotangent of x times the cosecant squared of x. So when I do that, cosecant squared times cosecant squared is cosecant to the fourth of x times the cotangent of x. And that's the same thing we have on the left-hand side. And there we go, we just verified. These are a little tricky. It's really an application of rewriting and simplifying. And that's an important skill to have when you get into calculus. And it's going to be important when we're going to be solving these in future lessons. It's all about knowing those identities and applying those identities because it's all about rewriting. All right. Thank you, and I'll see you in the next video.